NEC 409.1 scope states that this article covers industrial control panels and controllers designed to control industrial machinery and similar industrial applications. These panels incorporate one or more fused circuits meeting the requirements of 409.22 and typically include switches, relays, contactors, timers, and other components to provide control in industrial processes. Industrial control panels are usually constructed in accordance with UL 508 as standard for industrial control panels. Lighting control panels are usually constructed in accordance with UL 916 standard for energy management and lighting control equipment. NEC 409 covers UL 508 industrial control panels but does not specifically mention UL 916 lighting control panels. Many inspectors interpret NEC 409 as also covering UL 916 panels because they are similar in construction and purpose to UL 508 panels. Here is a summary of the key differences between UL 508 and UL 916 panels. Firstly, UL 508 panels are designed to control industrial machinery and similar industrial applications, while UL 916 panels are designed to control lighting systems. Secondly, UL 508 panels typically include switches, relays, contactors, timers, and other components to provide control in industrial processes, while UL 916 panels typically include dimmers, switches, relays, and other components to control lighting systems. In general, UL 916 panels are more likely to be used in commercial buildings, while UL 508 panels are more likely to be used in industrial settings. However, there is some overlap in the applications of these two types of panels. The decision of whether a particular UL 916 panel is covered by NEC 409 is ultimately up to the local electrical inspector. Inspectors may consider factors such as the construction of the panel, its intended use, and the specific requirements of the NEC 409 article. The scope of NEC 409 focuses on industrial control panels used for machinery and industrial processes. These panels must have fused circuits meeting section 409.22 and commonly feature components like switches, relays, contactors, and timers to manage industrial operations. UL 508 serves as the standard for constructing these industrial control panels. In contrast, UL 916 provides the standard for energy management and lighting control equipment, which are usually implemented in lighting control panels. While NEC 409 directly addresses UL 508 panels, it doesn't explicitly mention UL 916 panels. Nevertheless, the similarities in design and function between the two often lead inspectors to consider UL 916 panels as also falling under the purview of NEC 409. Key differences between UL 508 and UL 916 panels include their primary applications and typical components. UL 508 panels control industrial machinery, employing switches, relays, contactors, and timers. UL 916 panels, on the other hand, control lighting systems, often using dimmers, switches, and relays. Application-wise, UL 916 panels are more common in commercial buildings, while UL 508 panels are typically found in industrial settings, though some overlap exists. The final determination of whether NEC 409 applies to a specific UL 916 panel rests with the local electrical inspector. Their assessment takes into account the panel's construction, its intended use, and the specific stipulations of NEC 409. The interpretation of NEC 409 regarding UL 916 panels involves understanding the code's intent and the practical application of these panels. While NEC 409 primarily targets industrial control panels built to UL 508 standards, the similarities in functionality and construction often lead to the inclusion of UL 916 panels used for lighting control under its umbrella. Inspectors consider these factors to ensure safety and compliance in electrical installations. When evaluating whether NEC 409 applies to a UL 916 panel, the inspector will review several aspects of the installation. Firstly, the construction and components of the panel are examined to determine if they align with the safety and performance requirements outlined in NEC 409. Secondly, the intended use of the panel is considered, focusing on whether it is used in an industrial setting or a commercial building, as this can influence the interpretation of the code. Thirdly, the inspector will assess the specific requirements of NEC 409, such as those related to overcurrent protection, grounding, and wiring methods, to ensure that the UL 916 panel meets these standards. It is important to note that the interpretation of NEC 409 can vary depending on the local jurisdiction and the specific circumstances of the installation. Therefore, it is always recommended to consult with the local electrical inspector to obtain clarification on the applicability of NEC 409 to a particular UL 916 panel. To further clarify the distinction between UL 508 and UL 916 panels, it is helpful to consider their respective design and functionality. UL 508 panels are designed for industrial machinery and control systems, prioritizing robustness and reliability in harsh environments. They typically include features such as heavy-duty enclosures, high-capacity components, and advanced protection mechanisms. UL 916 panels, on the other hand, are designed for energy management and lighting control, emphasizing energy efficiency, flexibility, and user-friendly interfaces. They often incorporate features such as dimming controls, occupancy centers, and programmable lighting schedules. The components used in UL 508 panels are typically selected for their ability to withstand high currents, voltages, and temperatures, ensuring reliable operation in demanding industrial applications. In contrast, the components used in UL 916 panels are chosen for their energy efficiency, precision, and compatibility with lighting control systems. When evaluating the applicability of NEC 409 to a UL 916 panel, the inspector will also consider the overall electrical system in which the panel is installed. This includes assessing the voltage levels, current ratings, and grounding configurations to ensure that the panel is properly integrated into the system and meets all applicable safety requirements. Furthermore, the inspector will examine the wiring methods used to connect the panel to the electrical system, ensuring that they comply with NEC standards for conductor sizing, insulation, and protection. The inspector may also require documentation such as panel drawings, wiring diagrams, and component specifications to verify compliance with NEC 409 and other relevant codes and standards. In some cases, the inspector may request a field evaluation of the panel by a qualified testing laboratory to confirm its safety and performance characteristics. This evaluation may involve testing the panel under various operating conditions to ensure that it meets the requirements of UL 916 and NEC 409. Ultimately, the goal of the electrical inspector is to ensure that the electrical installation is safe, reliable, and compliant with all applicable codes and standards. By carefully evaluating the construction, intended use, and electrical system integration of a UL 916 panel, the inspector can determine whether it falls under the scope of NEC 409 and meets all necessary requirements. The interpretation of NEC 409 in relation to UL 916 panels requires a thorough understanding of both codes and their underlying principles. NEC 409 focuses on ensuring the safety and proper installation of industrial control panels, while UL 916 provides standards for energy management and lighting control equipment. The similarities in function and construction between these two types of panels often lead to questions about their compliance with NEC 409. Electrical inspectors play a crucial role in determining the applicability of NEC 409 to UL 916 panels, taking into account factors such as the panel's intended use, construction, and electrical system integration. Their expertise and judgment are essential for ensuring the safety and compliance of electrical installations involving these panels. To make an informed decision about whether a UL 916 panel is covered by NEC 409, it is important to consider the specific characteristics of the panel and its application. This includes evaluating the panel's components, wiring methods, overcurrent protection, and grounding system. Additionally, it is essential to consult with the local electrical inspector to obtain clarification on the code requirements and ensure compliance with all applicable standards. When evaluating a UL 916 panel for compliance with NEC 409, the inspector may consider the following factors. Firstly, the panel's listing and labeling, ensuring that it is properly certified by a recognized testing laboratory. Secondly, the panel's compliance with UL 916 standards, verifying that it meets the requirements for energy management and lighting control equipment. Thirdly, the panel's integration into the electrical system, assessing the compatibility of voltage levels, current ratings, and grounding configurations. Fourthly, the panel's wiring methods, ensuring that they comply with NEC standards for conductor sizing, insulation, and protection. Fifthly, the panel's overcurrent protection, verifying that it is properly sized and installed to protect against overloads and short circuits. Sixthly, the panel's grounding system, ensuring that it is effectively grounded to minimize the risk of electric shock. Seventhly, a panel's documentation, reviewing panel drawings, wiring diagrams, and component specifications to verify compliance with NEC 409. By carefully considering these factors, the electrical inspector can make an informed decision about the applicability of NEC 409 to the UL 916 panel and ensure that the electrical installation is safe and compliant. The application of NEC 409 to UL 916 panels can be complex and requires a thorough understanding of both codes and their underlying principles. While NEC 409 primarily focuses on industrial control panels, the similarities between UL 916 panels and UL 500 panels often lead to questions about their compliance with NEC 409. Ultimately, the decision of whether NEC 409 applies to a particular UL 916 panel rests with the local electrical inspector. He will consider various factors such as the panel's intended use, construction, and electrical system integration. By carefully evaluating these factors and consulting with the local electrical inspector, it is possible to ensure that the electrical installation is safe, compliant, and meets all applicable standards. To ensure clarity and consistency in the application of NEC 409 to UL 916 panels, it is helpful to have clear guidelines and interpretations from authoritative sources. These guidelines can provide valuable insights into the intent of the code and help electrical inspectors make informed decisions about compliance. Organizations such as the National Electrical Manufacturers Association and the International Association of Electrical Inspectors offer resources and training programs that can assist electrical professionals in understanding and applying NEC 409 to UL 916 panels. Additionally, consulting with experienced electrical engineers and contractors can provide valuable practical guidance on the proper installation and maintenance of these panels. By staying informed about the latest code updates, industry best practices, and expert opinions, electrical professionals can ensure that their work is safe, compliant, and meets the highest standards of quality. The interpretation and application of electrical codes like NEC 409 often require a nuanced understanding of the specific context and circumstances of the installation. While the code provides general guidelines and requirements, it is the responsibility of the electrical inspector to apply these rules in a manner that ensures safety and compliance while also taking into account the unique characteristics of the installation. This requires a combination of technical knowledge, practical experience, and sound judgment. Electrical inspectors must be able to evaluate the construction, intended use, and electrical system integration of a UL 916 panel to determine whether it falls under the scope of NEC 409 and meets all necessary requirements. They must also be able to communicate their findings clearly and effectively to the owner, contractor, and other stakeholders involved in the project. Effective communication is essential for ensuring that everyone understands the code requirements and that the electrical installation is completed in a safe and compliant manner. In addition to technical expertise and communication skills, electrical inspectors must also possess strong ethical principles and a commitment to public safety. They must be able to make impartial decisions based on the code and the facts, without being influenced by personal biases or external pressures. Their primary responsibility is to protect the public from electrical hazards and to ensure that all electrical installations are safe and reliable. The NEC is a living document that is constantly updated and revised to reflect changes in technology, industry practices, and safety standards. Electrical inspectors must stay current with the latest code changes and interpretations to ensure that they are applying the most up-to-date requirements. This requires ongoing education, training, and professional development. Many organizations offer continuing education courses and certification programs for electrical inspectors, helping them to stay informed about the latest code changes and best practices. By investing in their professional development, electrical inspectors can enhance their skills, knowledge, and credibility, and better serve the public. The role of the electrical inspector is critical for ensuring the safety and reliability of electrical installations. Their expertise, judgment, and commitment to public safety are essential for protecting people and property from electrical hazards. By staying informed about the latest code changes, industry best practices, and expert opinions, electrical inspectors can continue to play a vital role in the electrical industry. Considering the perspective of different stakeholders involved in electrical installations can provide valuable insights into the challenges and opportunities associated with code compliance. Electrical contractors, for example, are responsible for installing and maintaining electrical systems in accordance with the NEC and other applicable codes and standards. They must have a thorough understanding of the code requirements and be able to apply them in a practical and cost-effective manner. Electrical engineers, on the other hand, are responsible for designing electrical systems that meet the needs of the building or facility while also complying with all applicable codes and standards. They must have a strong understanding of electrical theory, circuit analysis, and power distribution systems. Building owners and managers are responsible for ensuring that their electrical systems are safe, reliable, and compliant with all applicable codes and standards. They must be able to understand the code requirements and work with qualified electrical professionals to maintain their electrical systems in good working order. By understanding the perspectives of these different stakeholders, electrical inspectors can better communicate their findings, address concerns, and work collaboratively to ensure that electrical installations are safe, compliant, and meet the needs of the community.